Hello, this is the wrap-up video for week one of the course. In week one, we were looking at analytics and business value. And so in this wrap-up video, I'm going to briefly go over the discussion from week one and then switch over to my keyboard where I will walk through a few things that came up on the first knowledge check. So to start with the discussion in terms of how businesses are using data and analytics in novel ways, the discussion kind of boiled down into four general themes. The first theme was really around using analytics and data to improve operational efficiency and the use of analytics and data in predictive modeling. Okay, and we see that all over the place. So examples there, someone had brought up the idea of trucking companies using predictive modeling. There was an example of Atropos Health using models to run analyses in seconds rather than in weeks. And I would say that processing of massive amounts of data is much more possible today. Certainly, if you went back 15 years ago, yeah, those things would be taking weeks, right? It would take a lot of resources, a lot of time. Those things now get done very quickly. And that relates a little bit to one of the articles that you read for the first week, the idea of the millisecond economy. That it's not only customers that expect things very quickly, it's also internal customers, right? So if you think about data being used within internally to an organization, if I go back in my CVS experience when I used to work, back 15 years ago at CVS, if I needed to pull a data set, I'd have to put out a request to what we call the data warehouse. And then like the next day I would get the data set. I guarantee that's not how it works any longer. I guarantee that now someone will fill out the fields that sort of say, here are the criteria for what I'm looking for. They click submit, and like within 5 minutes, within 1 minute, within 30 seconds, they get a file back, right? That's sort of how things work these days. And so analytics and the use of data allows for more of that type of decision making. Second theme had to do with businesses using data to help customize customer experiences, optimize revenue. So examples there, Starbucks. Starbucks is really good at using customer data to offer personalized services, as well as to get a sense of the demand, to do a better job of forecasting demand. Another example, Google AI shopping. Someone had brought that up, and the idea that you get these personalized discount offers or products that are, again, customized to your interests and to your searches. So yeah, we see a lot of that. We see the example, again, from the article that you read for week one, that Netflix effect, right? The idea that people have an expectation that companies are going to be able to use the data from their past history to be able to kind of personalize products and services. So I think that's more of an expectation these days. A third theme had to do with transforming products and services. So I thought this was really interesting. People brought up examples of companies not only using data to like improve their operational efficiency, but then using insights from that data and maybe selling that as a product, right? So Uber, really great example. Not only is Uber using data to kind of improve and optimize its offerings, but then it has a ton of insights in terms of driver behavior and customer behavior that it can now sell, right, as a product. Clearwater Analytics, automating and validating and auditing massive data sets very quickly. So again, companies really kind of using this data much more strategically. And then the last theme had to just do with ethics, privacy concerns, environmental concerns, concerns about governance. And I think that particularly as we see the rise in interest with like AI tools and companies trying to figure out how to use these AI algorithms and how to generate value and revenue from these AI systems, I think a lot of this stuff is like the Wild West. And we're going to get more into this when we talk about data quality, actually, which was this past week. So if you've watched the lecture from this past week, you would have already kind of heard me talk a little bit about Upton Sinclair's The Jungle as sort of an expose of the meatpacking industry in Chicago, and the fact that as a result of that expose, a lot of regulations and regulatory bodies came into existence to protect us from the danger of not having food safety, right? And I think that we're kind of in a place right now with data and analytics and AI where governments, businesses, trying to figure out how to get a handle on this. So it's not decided yet, right? This is not settled ground. So there's a lot going on here. People talked about the impact to the environment. Data centers use tremendous amounts of energy, privacy and trust concerns. Every time there's a leak of data, that sort of chips away at people's trust. And then healthcare, ethical people had examples of concerns about ethical use in healthcare. Very, very important consideration. So again, a very interesting conversation, very interesting discussion. In the feedback on Knowledge One, I think a bunch of people mentioned they really enjoyed the discussion. And so hopefully you found it very useful. Keep it going. Just a reminder for those, there were a couple people that only posted once to the discussion. You actually have to post twice for full credit. So you post your answer to the prompt, and then you have to respond to one other student to get full credit. So I think there are 2 or 3 people that only got half credit on that first discussion because they only posted their response, but they didn't respond to someone else. So just keep that in mind that you have to post twice to the discussions. I'm going to switch over to my keyboard, go over a few things from the knowledge check, and then I'll see you on the other side. Okay, so there's just one question I wanted to quickly go over from Knowledge Check 1. So I do take a look at how people did on these knowledge checks, and if there are any questions where it looks like people lost points, I will typically go over those during these wrap-up videos. For Knowledge Check 1, all but one of the questions I think got 100% of people got correct. So obviously I'm not going to go over those questions. The only one that gave a little bit of trouble for some people was this question right here, question 3. And so let's just quickly walk through how this works. So notice all of these are assignment statements. And so, whenever there's an equal sign, basically the way that Python processes this is it looks on the right side of the equal sign to look at whatever that value is, and then it saves that value to whatever you've called it on the left side of your variable. Okay. So these first 3 rows are kind of just basic assignment statements. This is saving the number 5 in your computer's memory as the letter X. This is saving the number 10 with the letter Y. This is saving the number 20 with the letter Z. Then we get down here, and now again, it looks first on the right side, so it's now going to try to evaluate what's happening over here. So it says, well, what's the value of X? Well, that's 5. What's the value of Y? That's 10. So 5 minus 10 plus 10, that ends up being the number 5. And so it evaluates this to the number 5, and then it saves it in your computer with the letter W. And then we get down to this line, and again, it looks on the right side first, and it says, well, what is W? W is the number 5. And now it saves the number 5 into your computer's memory as the letter Z. So it writes over this 20, and it resaves Z with the number 5. So the correct answer for both of these was both variables Z and W are equal to 5. By the way, you could have copied this over into Jupyter. So I have a Jupyter worksheet listed here. One thing to note, by the way, though, is in Python, indentation actually matters. So I'm going to remove these indents. Otherwise, you might get an error message. So here's the code that was in the Canvas quiz. I can go ahead and run this. Remember, the keyboard shortcut is Shift and Enter, and that runs it. Now, it looks like it didn't run, right? But notice the number 1. That number 1 in the brackets means it did run this code. Now, it's not showing me anything because all of these are just assignment statements. So all of these lines of code, all they're doing is saving values in your computer's memory. We've not actually told Python to show us the value. So finally, if I want to see what is the value of Z, remember the way that I do that is I actually just type the name of the variable and run that. It's 5. And by the way, what is W? That's also 5. Okay. Yeah, you could run this in Python just to kind of check your work. Okay. That was the only question from the knowledge check that came up. I did take a look at your answers to the first question on the first knowledge check, the feedback, and a couple questions kind of came up. So one person asked, with importing packages, why wouldn't you just import all the packages at the top of your script, like they've seen in other scripts and other coding languages? And in fact, I would tell you in good coding practice, that is exactly what you'd do. So, for example, if I were writing a script to build a model, and I knew that I had to use like three different packages, I would put that right at the top, right? So I'd have like import pandas. Maybe I need to use NumPy, which is another package that's awfully often used for uh, analysis. I might have to import sklearn.model selection. Just trying to think of some packages that we're going to be using this semester. Import sklearn.tree to create a decision tree. So I might just run all of those right off the bat at the top of the script, right? That's very common. As I'm teaching this to you in the hands-on videos, I'm typically kind of showing you the packages as we get to them. And so that's why we're not necessarily importing them right at the top. And it's more because as I'm going through the exercise, all of a sudden, aha, we need to use a new package. So let's go ahead and import the package now. That's just because it makes more sense to do that in the hands-on videos, because if I load packages at the front and you don't really understand why I'm loading the packages, I have found that that's a little bit more confusing. So that's just the reason why when we're kind of going through these different worksheets, like if I look at the worksheet for week 2, pandas, which is something I talk about in week 2, I don't import that till I get down here. Well, it's because I'm not talking about pandas till I get down here. So if I imported pandas all the way up here, but then I start talking about data types which have nothing to do with pandas, that might be a little confusing. So that's really the only reason that I do that way. But the person that brought this up, they're absolutely correct that in good coding practice, if we kind of think about good sort of coding hygiene, yes, you would typically put all of your import statements at the top of your script. Okay, and that's true in any coding language. It's certainly also true in R. Speaking of R, a couple people mentioned that they like the similarities to R, although there are some differences as well. And yeah, to the extent that you can recognize the similarities, I think that helps to learn a new language. And there are similarities between R and Python, although there are obviously differences as well. So throughout the semester, in the hands-on videos, to the extent that I recognize similarities between the two coding languages, I will typically point those things out. And again, I do think that that's good for you to make note of, because it's one way to try to learn how this stuff works. Okay. Someone had asked about the fact that they thought it was interesting that we're using different coding environments. For R, you used RStudio. I'm not quite sure what you use for SQL, but then over here you're using Jupyter for Python. And I'll tell you, there actually are code editors that are flexible. And Jupyter, actually you can run R in Jupyter. We don't typically use Jupyter for R. We just have you download RStudio onto your laptop, because it doesn't take up that much space and it's a little bit more straightforward. But it turns out Jupyter, Jupyter, the R in Jupyter actually stands for R. Jupyter runs 3 different coding languages. It runs Julia, which is a coding language that people use in math. It runs Python, that's where the PY comes from. And then the R comes from R. So you actually can just use Jupyter for both R and Python. And I will also tell you, with SQL, there are packages in Python that you can load that allows you to run SQL code to connect to a database and then run SQL code to get back data from a database. So there are ways that you can actually use Jupyter, for example, for all 3 of those things. Okay, and there are other coding editors out there that work. One person had asked for recommendations for a code editor that you could use offline, and I will tell you, actually, Jupyter you can download to your computer. Throughout the semester, we're going to use Jupyter Hub, and the main reason for that is because in Jupyter Hub, first of all, you don't have to worry about, for those that don't want this on their computer, it turns out it's a little bit complicated to download this. And so I've just found that it causes a lot of problems for people that aren't particularly interested in having Jupyter on your computer. Secondly, because I am connected to a GitHub, when you log in, all of the files that I've uploaded automatically load into your directory of files. So it makes it a little bit easier for me to just give you files that you're going to need. But at the end of the semester, I will actually send out instructions for how you can download Jupyter directly onto your laptop, so that after this class you can continue to use Jupyter for any of your Python coding if you enjoy this particular tool. There are a ton of tools out there, and there's nothing magical about Jupyter. I will say though, because I know like about a year ago I had a student that gave me feedback on a course eval saying that he had wished that we had not used a play environment for Python. This isn't a play environment. This is a real code editor. I have a friend that works for a startup. He's a coder. He actually uses Jupyter to do his Python coding. So it is a real editor. This isn't like a fake editor that we're using for the purposes of this class. People actually in the real world with jobs that revolve around Python coding, they actually do use Jupyter upon occasions. One question came up about a display thing. So I think with this example, from SciPy, it came from SciPy.stats import norm, and then it was like norm.cdf -1. Okay, and the person had brought up the fact that on the video, when you run this, when I ran this on the video, it only showed a number. But when you run this yourself, it gets this np.float64 thing. Notice it now does that for me. That's a change that happened about a year ago. It's just a display change. And now, like if I were recording that video today, this is what would appear. Okay, so it's just a display thing. It's just telling me this is a float. And if you haven't gotten to week 2's videos yet, a float is just a number that's using decimals. This is numeric and it has a decimal. We call that a float. This is just literally saying it's a float, and here's the actual value that gives me the result from that. If you didn't like this appearance, I mean, you can use the print function. I just don't think that's necessary. You know, I think you just, as long as you kind of don't get hung up on the fact that it's going to say np float, or if this were a whole number, it would say np.int64 for integer. It's just a display thing, but it's not going to affect the way in which you can use these numbers, right? If I wanted to do math with this, I could do math with this. That display thing doesn't get in the way. Okay. I think one more question came up that I wanted to talk about. Someone had asked, is there a way to see the correct order of operations for a function? And I think what they're referring to was like, if I bring up Excel, I happen to have Excel open here. So the nice thing about Excel is when I start typing a function, XLOOKUP, it gives me on-screen help for like what the different arguments are and the order of the arguments. So the unfortunate thing is in Jupyter, there's no direct comparison to that. There's no way directly that you can get that on-screen help. However, there is a keyboard shortcut. So let me show you an example. So for example, if I did the round function, once you start typing a function, if you type the parentheses, inside the parentheses, if you type Shift Tab, that turns on-screen help. Now notice that that's just the documentation from the help command, but it quickly gets it to you so that you don't have to use the help command, or you don't have to come up here and get like contextual help. I mean, the contextual help shows you the same thing, but this is just a really quick way. Shift and Tab turns that on. Okay. Now in this one, it's helpful because it tells us the parameters. As you saw from the video, sometimes it's a little bit less helpful. Norm.cdf parentheses, and then I do Shift Tab. And unfortunately, this one's a little bit less helpful, right? And that's the problem with open source. People write these functions, and the way that they're writing the help documentation may not always be exactly user-friendly. So if it's helpful, Shift Tab gives you the help documentation. Another example, in week 2, we look at pandas.read underscore CSV. Okay, well, shift tab. It turns out there are a ton of different parameters here. Okay, and if I keep scrolling down, it actually gives me descriptions of these parameters. So again, you can kind of dig into this. What I will tell you though is if it's not clear how to use something and the help documentation's not helping, go over to ChatGPT, go over to Copilot or Gemini, go to an AI source and ask them, how does this function work? What are the parameters? Can you explain the parameters to me? I think AI tools are great for that. I mean, you can also Google. Often you'll see that if you're someone that has a question about how to use this CDF function, you're likely not the first person in the world that's ever wondered how this function works. And so simply Googling it probably will take you to some Stack Overflow pages where someone's asking questions about how to get this to work. But I will also tell you AI tools tend to be very good at this sort of thing. So I think that that's a good use of AI. Okay, so that's really all that came up in the feedback. Okay, so welcome back. Hopefully you found that helpful. So for week 2, I think there are only 2 assignments that are due, Knowledge Check 2 and the second discussion. Both of those are due on Monday. Okay. And that's just a reminder with Coding Project, if you want to work in a project group, I am asking you to sign up on Canvas under the people link. I think you have another week and a half to finalize that, but I am asking you to sign up for a group if you want to work in a group. If you want to work on your own on the Coding Project, that's perfectly fine. You don't have to do anything. I'll just assume if you didn't sign up for a group, I'll assume that you're going to work on your own on the Coding Project. And then the next step, start looking for data. Again, I do have a data set. If you get stuck and you cannot find data, I can give you a data set. So don't stress too much about this, but I don't want you to start there. Okay. I think it's a more interesting project if you find data that's relevant to you, rather than me just give you a data set. So you could try Googling. Google has like a data set search. So you could try using Google's data set search to find sources for freely available data sets. I know in the instructions for the Coding Project, I mentioned not to use Kaggle. You can use Kaggle. I don't want to say you can't use Kaggle. Kaggle is a website that has a bunch of data sets. What I'm trying to avoid is you using a data set where there are a ton of posted models and posted analyses. I'd prefer for you to avoid that, but you may find data on there that's not been heavily used. Certainly use AI tools to try to find data. Use ChatGPT, Gemini, Copilot. It won't actually give you a data set, but it can give you links to data sets or links to sources that have data sets. So try all of those things, see what you come up with. If when you're searching for a data set, you find something and you're not sure if it's would be good for the project, feel free to reach out to me. You can send me an email. Let me know a little bit about the data set, how many rows, how many columns, what type of data is it? And I can give you feedback on whether I think it'll work for the project. In general, dimensions for the project, in terms of number of rows, you do want it to be large enough that it's useful. So I think that you want to make sure there's at least 300 rows of data. That's still small, better to be in the thousands, but at least if you have 300 or more, I think it'll be fine with the models we're building. If you start getting below 300, that's kind of small for what we're going to be doing, okay? In terms of columns, 5 to 10 columns, okay? You don't really have to use more than like 10 columns. I don't think it makes sense to have less than 5 though. Again, you're not going to find much that's interesting if you have like only 3 columns in your data set. A good mix of quantitative and qualitative, so numeric and categorical data, I think that's ideal. Better to have numeric. You can turn numeric into categorical. We'll talk about that when we get to feature engineering. It's worse if you only have categorical because you can't turn that into numeric data. So make sure that there's at least some numeric data in the data set that you find. I've had teams in the past try to use like survey data where everything was a categorical question. And I'll just tell you, they were miserable. It made the project so much more difficult. So try to avoid that type of data. But again, if you wanted me to take a look at the data set, that's great. If you have a data set that's really, really large, like in the millions of rows or like 300 columns or something like that, well, first of all, even if you have 300 columns, you don't have to use all 300. You don't have to use all the columns in your data set. Again, you can pick out 5 to 10 that you think are the most relevant for your project, okay? In terms of the rows, the problem there is if you're in the millions of rows, you may have difficulty reading that into Jupyter Hub. Either it'll take like 15 minutes every time you try to load the data set in, which will get very annoying very quickly. Or it may eat up all of your available memory and it will crash your hub. So what I would say is if you've got a data set that's like millions and millions of rows and it's you're having a hard time loading it in, I'm okay if you open that first like in Excel and then just select out a couple 100,000 rows, okay? And you might want to randomly select the rows. You can use the rand function, which creates a random number between 0 and 1. Create like a column in Excel using the rand function, and then filter. And let's say you want 50% of the rows. You would filter and select any row that's greater than or equal to 0.5. That's a way to kind of randomly select rows. So you can pare down your data set in something like Excel first, if you can't get it into Jupyter, and then save that and then use that file. I'm okay with you doing something like that, okay? Okay, that's all I have for this week. Have a great weekend. Hopefully it doesn't snow too much this weekend, and I will be seeing you again next week. Bye-bye.